Hello everyone, this is Matt Rogers from Salisbury Elementary School. Today we're here to talk about Unit 2, Lesson 13. This focuses on how do I use different methods of two-digit multiplication. Over the last few days we spent most of our time looking at how to multiply two-digit by two-digit numbers using our area model, and we'll continue to use our area model, but we're also going to look at some of the other methods for multiplying. Our first method we're going to look about is our place value sections method. I'm going to zoom in real quick on this. Go a little bit further. Our place value sections method has our area model as demonstrated on the screen here. Okay. We break it into our place values. So 67 has 60 and 7, and 43 is broken into 40 and 3. Similar to how we've done it before, we continue by more or less doing the individual place value multiplication. So I have 40 times 60, 40 times 7, 3 times 60, 3 times 7. Then I get all four of those partial products as shown on the screen, and I'll add them up. We really do a lot of the work while inside the area model, but to make it nice and neat, we'll move over to the right-hand side, do the partial product equations, get the answers, and then line those answers up based off the place value. When I have all the partial products, I add them up to get a final product. So that is our place value method. When I scroll down to expanded notation, this is our next method we were talking about. So again, I have the area model with the breaking down into the expanded notation, and the work within the area model is the same. What I have in addition is I had these lines that kind of identify the different multiplication problems. When I go over to the right hand side, I see that I write my equation vertically. So I have 67 times 43. In this case, 67 breaks into 60 plus 7, and 43 is 40 plus 3. Then below, I understand and identify each of my multiplications. So the tens by tens place, which is represented by 40 times 60, our tens by ones place, which is represented here, our ones place by tens place, and our ones by 1. Again, this creates the same four equations for partial products, which give the same partial products. When I add them up, guess what? I get the same answer again. Continuing down, the last one is algebraic notation. And if you remember from when we were doing one by three digit or 1 by 2 digit multiplication, this is the one that we say is related to distributive property. So I'm going to distribute the 40 onto the 60 and distribute it onto the 7. Distribute the 3 onto the 60, distribute the 3 onto the 7. And when I go over to the right hand side, I can see that distribution in action. So I have in our independent, our expanded problems, I have 40 plus 3 times 60 plus 7, and I show how I distribute the 40 onto the 60, 40 onto the 7, then the 3 onto the 60, and 3 onto the 7, which gives, again, the same four partial products. When I add them all up, we get the answer. Now, the additional activity that we worked on was our new groups above, new groups below. While this is a helpful one, I'm not going to spend too much time on it because it is one that confused the students more than benefit. What I have is I continue to have our multiplication problem of 67 times 43. On the left-hand side, I see how I break down the problem. So I have the partial products actually on the left of the problem, and I identify how I got to those partial products on the right-hand side. It gives me the same partial products that give me the same answer. When I look at the new groups, this is a little bit more challenging. So I'm going to actually change my color and point it out a little bit more for you guys. When I do 7 times 3, I'm going to start in the ones place. I get 21. Okay? So I almost write the 2 as a exponent above to remind me. And then I do 6 times 3, which gives me 18. So right now I have a 12, which it starts in the tens place, so I could almost write it as 120, and an 81. When I do 40 times 7, you'll see that since I start with a 40, I put the 0, and then I have 28. Then I do 4 times 6, or 40 times 60, which gives me 24. I put the exponent, or the carried number, up above, and then, based off line place value, I will add straight down our lanes. I know that kind of looks a little confusing, but it is the method that we did show today to make it a little bit easier. What we call our shortcut method is this one, which kind of takes the same approach but makes it a little bit easier. So again, our first step is 7 times 3, which gives me 21. So I put my 1 digit here, down below, and then I carry the 2 above. Okay? Then I do, in our next step, 6 times 3, which is 18, and I take that 2 and I add the 2 to the 18, which gives me 20. I already had the 1 from the 7 times 3, and now with the 20 plus 18, or 180, I get 201. So now I've done all of my multiplication with the 3. Now I have to approach it with the 40 times 7. So 4 times 7 is 28. So again, I write another exponent and I carry my 1. Now since it's 40 times 7, it's actually 80. Then when I move to step 4, I take that 2 that I carried over. When I do 4 times 6, it gives me 24 plus that additional 2, which gives me the 26. When I add 201 by 268 with a 0, so it's actually 2,680, I get our answer of 2,881. Well, I know that probably looks confusing. It is very similar to addition and carrying numbers, just set up so you can see the different multiplication problems. The process below is the same thing, except for instead of multiplying, carrying above, you just carry below. So you can see the 2 are carried below for the problem. For the rest of the class, we spent some time looking at how to create problems in the area, array, or equal groups method, more or less just ways that you could rewrite multiplication problems. And finally, we did a general assessment. For the most part, that's all we covered today. I know that's a lot because those are 4 dynamically different but relatively similar multiplication methods. If you have any questions, let me know, and I hope this was helpful.